Identity and access management, commonly known as IAM, represents one of the most critical components of modern cloud security infrastructure. IAM enables you to manage access to cloud resources, ensuring that only authorized users and services can access specific resources. This fundamental capability forms the backbone of cloud security. IAM acts as a security gateway between users and cloud resources. It controls who can access what, when they can access it, and what actions they can perform. IAM is essential for maintaining a secure cloud environment for several critical reasons. It prevents unauthorized access to sensitive data, ensures regulatory compliance with audit trails, and significantly reduces the costs and risks associated with security breaches. The Tesla hack serves as a stark reminder of what happens when IAM controls fail. Hackers successfully hijacked an Amazon cloud account by exploiting compromised IAM credentials, then used Tesla's cloud resources to mine cryptocurrency. This incident demonstrates the critical importance of proper IAM implementation. Proper IAM implementation is not optional in today's cloud environment. It serves as the foundation of cloud security, protecting your organization from unauthorized access, data breaches, and compliance violations. Understanding and implementing IAM correctly is essential for any cloud security strategy. IAM roles and policies are fundamental components that work together to control access to AWS resources. Understanding their relationship is crucial for implementing effective security controls. IAM policies are JSON documents that define permissions, specifying exactly what actions users and workloads can perform on AWS resources. They act as the rulebook for access control. IAM roles, on the other hand, manage permissions between services and resources. They provide a secure way to grant permissions without embedding long-term credentials in your code. Roles act as a policy administration layer. Multiple policies can be attached to a single role, combining their permissions to define what the role can do. When policies are attached to a role, they combine to form the complete set of permissions that the role possesses. This modular approach allows for flexible and maintainable access control. Roles can be dynamically assigned and transformed based on requirements. Here we see how an EC2 instance role can be transformed into a Lambda execution role, demonstrating the flexibility of IAM role management. To summarize, policies define what actions are allowed, roles define who can perform those actions, multiple policies can be attached to roles for combined permissions, and roles serve as the policy administration layer in AWS IAM. Service accounts are a fundamental component of cloud security, enabling applications to authenticate and access AWS services without human intervention. A service account is a non-human identity that allows applications and services to authenticate automatically without requiring interactive login credentials. IAM roles for service accounts, or IRSA, allows applications running in containers to assume IAM roles and access AWS services securely. Every AWS API request must be signed with valid credentials. This three-step process ensures that only authenticated applications can access AWS resources. The signing process includes generating a cryptographic signature with a timestamp, which AWS validates to ensure the request is authentic and has not been tampered with. The complete authentication flow demonstrates how applications securely access AWS services through service accounts and temporary credentials. This authentication mechanism ensures that applications can securely assume different roles and access only the resources they are authorized to use. Service accounts provide a secure, automated way for applications to authenticate with AWS services, eliminating the need for hard-coded credentials while maintaining strict access controls. The principle of least privilege is a fundamental cornerstone of identity and access management security. This principle ensures that users, roles, and services receive only the minimum permissions necessary to perform their designated tasks. This security principle requires that we grant users and services only the specific permissions they absolutely need, nothing more. Think of it as providing exactly the right keys for the doors they need to open. When users or services have excessive permissions, they create significant security vulnerabilities. If an account is compromised, attackers gain access to far more resources than necessary, potentially leading to data breaches and system compromises. The implementation of least privilege follows a systematic approach. First, we start with zero permissions. New users, roles, and services begin with no access rights whatsoever. Next, we add permissions incrementally, granting only what is immediately required for specific tasks. Each permission is carefully evaluated and justified before being granted. Regular auditing is essential to maintain least privilege. We continuously review permissions to identify and remove any access rights that are no longer needed or have become excessive over time. AWS IAM Access Analyzer is a powerful tool that helps implement least privilege by analyzing resource policies and identifying unused permissions. It provides findings about external access and helps you understand which permissions are actually being used. To successfully implement the principle of least privilege, follow these best practices. Start with zero permissions, grant only minimum required access, review permissions regularly, utilize Access Analyzer findings, and maintain documentation for all permission justifications. These practices form the foundation of a secure IAM strategy. Remember, the principle of least privilege is not just a one-time implementation, but an ongoing security practice that requires continuous attention and refinement to maintain a robust security posture. IAM hierarchies represent the structured relationships between different identity and access management components within an organization. Understanding these hierarchies is crucial for effective permission management and security implementation. At the top of the hierarchy sits the organization, which serves as the root container for all IAM resources. This organizational level provides the foundational structure for managing identities and permissions across the entire enterprise. The second level contains users and groups. Users represent individual identities that require access to resources, while groups allow for efficient management of multiple users with similar access requirements. Groups enable administrators to assign permissions collectively rather than individually. Roles form the third level of the hierarchy. Roles are collections of permissions that can be assumed by users, groups, or services. They provide a flexible mechanism for granting temporary access and implementing the principle of least privilege across different operational contexts. At the bottom of the hierarchy are policies, which contain the actual permission statements. Policies define what actions are allowed or denied on specific resources. They are attached to roles and provide the granular control necessary for secure resource access. This hierarchical structure enables permission inheritance, where access rights flow from higher levels to lower levels. When a user assumes a role, they inherit all the permissions defined in the policies attached to that role, creating a clear and manageable access control system. Now we will examine a more complex hierarchy that demonstrates cross-functional access patterns and shared resource management within enterprise environments. Complex enterprise environments often require cross-functional access patterns. Here we see three departments that need to share access to common resources while maintaining appropriate security boundaries. Shared service roles enable multiple departments to access common resources like databases and storage systems. This approach reduces policy duplication while maintaining centralized control over resource access permissions. The policies attached to these shared roles define the specific permissions available to each department. This hierarchical approach ensures consistent access control while enabling the flexibility required for cross-departmental collaboration. Understanding these hierarchical relationships is essential for implementing effective IAM strategies. The visual representation helps administrators identify potential security gaps, optimize permission structures, and maintain compliance with organizational security policies. The token exchange process enables seamless integration between external identity providers and AWS services through IAM Identity Center. The process begins with an external identity provider, such as a corporate directory service or third-party authentication system, which issues authentication tokens to users or applications. This external token is then presented to AWS IAM Identity Center, which acts as a trusted intermediary in the authentication process. IAM Identity Center validates the external token by verifying its authenticity and checking that the issuing identity provider is configured as a trusted source. Upon successful validation, IAM Identity Center generates a new AWS-compatible token that contains the appropriate permissions and attributes for accessing AWS services. The newly issued AWS token can now be used to authenticate and author requests to various AWS services, providing secure access based on the original external identity. This token exchange mechanism eliminates the need for users to maintain separate AWS credentials while ensuring that external identities can securely access AWS resources with appropriate permissions. The token exchange process provides a secure, standardized method for integrating external identity systems with AWS, supporting modern authentication patterns and zero-trust security architectures. Now we will examine a practical implementation of the least privilege principle in Google Cloud Run. This example demonstrates how to replace default service accounts with custom accounts that have minimal, specific permissions. The default service account in Cloud Run typically has broad permissions, including editor role access. This violates the principle of least privilege and creates unnecessary security risks for your application. Step 1 involves creating a custom service account specifically for your application. This account will be configured with only the permissions your application actually needs. Step 2 requires identifying the exact permissions your application needs and assigning only those roles. For example, a typical web application might only need Cloud Run Invoker, specific storage access, and database client permissions. Step 3 involves deploying your Cloud Run service with the custom service account. The service account flag ensures your application runs with the minimal permissions you configured, not the default broad access. This comparison illustrates the significant security improvement achieved by implementing least privilege. The custom service account approach reduces the attack surface, improves compliance, and makes security auditing much more manageable. Following these implementation best practices ensures that your least privilege approach is both secure and maintainable. Remember to start with minimal permissions, test thoroughly, and maintain proper documentation for ongoing security management. We begin with a real-world security breach scenario to demonstrate the critical importance of proper IAM configuration. This roleplay will show how IAM misconfigurations can lead to devastating security incidents. Our scenario involves a web application with a service role that has been granted excessive permissions. Instead of following the principle of least privilege, this role has full access to multiple AWS services, creating a significant security vulnerability. Now we witness the attack unfold. An attacker discovers an unpatched vulnerability in the web server, allowing them to gain initial access to the system. Step 1. The attacker exploits an unpatched vulnerability in the web server, gaining initial access to the system. Step 2. Once inside, the attacker discovers AWS credentials stored in the compromised instance, allowing them to authenticate to AWS services. Step 3. Using the stolen credentials, the attacker assumes the overprivileged IAM role, gaining administrative access to critical AWS resources, including databases, storage, and compute services. The consequences are severe. The attacker exfiltrates sensitive customer data, deploys cryptocurrency mining software, installs additional backdoors for persistent access, and triggers multiple compliance violations. This breach was entirely preventable. The root cause was IAM misconfiguration, specifically, the violation of the principle of least privilege and inadequate security monitoring. The analysis reveals multiple IAM misconfigurations that enabled this attack. The service role had excessive permissions, there were no regular access reviews, multi-factor authentication was not enforced, monitoring was inadequate, and long-term credentials were improperly stored. The solution involves transforming our security approach. We must implement proper IAM roles with least privilege access, ensuring each service has only the minimum permissions required for its specific function. Now we examine the essential best practices that prevent such security breaches. These practices form the foundation of a robust IAM security strategy. The first 3 critical practices are implementing least privilege access by granting only minimum required permissions, conducting regular audits to review and remove unused permissions, and enforcing multi-factor authentication for all console access and role assumptions. The remaining essential practices include implementing role-based access control to simplify permission management, preferring IAM roles over IAM users for applications and services, and continuously monitoring AWS CloudTrail to track all credential usage and IAM activities. Continuous monitoring and proactive security measures are essential for maintaining robust cloud security. Organizations must implement comprehensive monitoring solutions and establish incident response procedures. A comprehensive monitoring strategy includes CloudTrail monitoring for real-time IAM activity tracking, Access Analyzer to identify unused permissions, automated alert systems for anomaly detection, and compliance checks for automated policy validation. Security breaches caused by IAM misconfigurations are preventable through proper implementation of security best practices, continuous monitoring, and proactive threat detection. Organizations must prioritize IAM security as a fundamental component of their cloud security strategy.